welcome you back to Think Tech Hawaii's Humane Architecture show. This happening to be our 284th show, and thanks to our producer, Eric. Here you see which accumulated viewer you are. Thank you for that. And we're back with three of us already in volume 19, I guess so, or 18, somewhere there, with the Boston Behnisch Booster, with Matt Noblett, who runs the Boston Behnisch office. And we think we need his booster. And we is us, DeSoto Brown in his Bishop Museum, and me, Martin Despang, in his Grand Hotel in Waikiki, that the drywall people are knocking on the door. And we're going to talk about technology in macro and micro in a bioclimatic way in a second. Welcome, guys. Before we get back to the subject matter, some breaking news here, and I pass this on right away to you, Matt, because you're the most expert on this happening as of a few days ago.
Yeah, I think it was Wednesday of last week, about midday. Yeah, Rafael Viñoly passed in his office, which is probably where everyone would have expected it to happen, just knowing his kind of total obsession and dedication to being in the office and working there. And yeah, it was, it was obviously somewhat unexpected, but he was 78 and had influenced a lot of people's careers. Certainly mine was started there after spending about 9 years with him. And obviously that makes a big impression. So yeah, I mean, I think I would just say we all are thinking about the folks left behind in the office, and they're going to forge forward, I'm sure. But and of course, his family. But yeah, on sort of a sad note to end the week last week.
Yeah, and just like you, DeSoto, and I, we actually had a heads up on Jimmy Carter, our mentor in many ways. And since he gave us a heads up, we were able to thank him in one of the recent shows. And intuitively, you met too, because when we shared a couple of shows ago that, you know, you had your apprentice years there, you already thanked him for that. And you said you learned a lot. So I guess, you know, he could have heard that when he was still around. Hopefully he heard it. So where
he was probably like 15,117 number.
Yeah, and you know, architects dying in their office and being their dream. That reminds me of your business partner Stefan Behnisch, who in that tandem bicycling show shared with everyone to say, I don't want that to happen, and learning from his father Günther, who couldn't let go. And so he promised himself and the audience to say, I want to, you know, I have these great partners, business partners as you, and they're ready to keep the ball rolling, and they don't need me anymore that much. You know, that's another way that he was sharing with us, right? And people on a brighter note, on a better note, people influencing us and having mentored us. That gets us to the next slide, which is the other breaking news on a more positive level here, and this is about what basically the biggest award, the Nobel Prize of Architecture, is the Pritzker Prize from the Pritzker family in Chicago. And it went to David Chipperfield this time. And talking where we got the news from, you said you heard about the passing of your former boss through Uruguay, right? Through a colleague from and a newspaper from there. I had how did our friend Ron Lindgren call himself? An octogenarian, I guess, if I remember that correctly. So he and my dad, Günther Despang, were both faster than me in giving this news to me, and basically sharing that with us. Here's the email by Ron that he sent to me. And in this case, what Rafael was for you, David, is for me in a more informal way, because many years ago, actually about almost a quarter of a century now, that's how time flies by, he was coaching me and giving me an award by the Architectural Review that is also about what Stefan and Günther had going on. There is obviously collaboration, but as Stefan shares, there's also competition. If you're the son of an architect, that, is both, easy and also not so easy. So we share that as well. So the sort of emerging part of us, represented from me, applied for this award with the tram stations. We were one from, I think, 30 chosen from 900. And then David was fighting for me and convincing Billy Chen, who had some worries about the tram stations being too decorative in their multitude of materialities. And he was convincing her. And the book, you and I, through your Nord LB and our kindergarten, are together in the Fate, and the following Fate in the Destination Architecture. We happen to be side by side, us with the canopies for the subway in Bochum. So he's following me within that typology of transportation. And again, I'm very happy for him for having gotten the award. And let's contemplate about that a little bit from our angles. It's sort of a return to the last Pritzker Prizes. While in the sort of original past, they always went to architects who did very sort of upscale, projects on a large sort of a civic scale, museums and, large buildings of various kinds. While in the recent past, the jurors went more to people with like social approaches, like the French couple and the guy from Portugal, right, who did social housing. And now it sort of defaults back to that Chipperfield does more of the project typologies that architects got the Pritzker Prize originally for. However, what you hear now being echoed in the press, less with a starchitectural attitude. Although this year in The Guardian, which Ron forwarded to us, it says from shop designers to starchitect. But in all the interviews you hear with him, he's very refreshingly the non-starchitect, and it's more the opposite, that he says all these people are actually more talented than I, and I faked it at the very beginning. And the way I don't think this is marketing. As far you can never tell unless you meet the people in person. My father had the chance to actually hear him speak at an event in the Both Günter's home in Dresden recently, and got that sort of same impression, right? And I want to point out the where you guys are touching base architecturally, Matt, is in Hamburg, because you built the Marco Polo Tower there some years ago, and he won a competition for the Elb Tower, which Elb is the river there, the Elbe. And that Elb Tower is supposed to be, I think it broke ground already, and it will be next to you. And while there's a video out there that I recommend, that, and this is all the Berlin office of Chipperfield that is doing a lot of the work. It's not the original one in the UK. And they have this sketch there, this napkin sketch there, where they have Herzog de Meuron's Elbphilharmonie, which, by the way, is one of the three most controversial projects that got us Germans, makes you guys think about German engineering and sophistication, because they all ended up being, delayed too much, and also budget blown too much. And so anyways, there's a sketch of the Elbphilharmonie that they say, we just basically do this ensemble of continuing or completing the swooping curve. Well, that might be on the macro level, but on the micro level, where we're going next to study further your the making of your thinking of the architectural detailing here, I'm more optimistic and this is a preview of a show, DeSoto, you and I want to do, that's working titled Tropically Tempered or so, where we're going to talk more about that. This is the facade mock-up of the Elb Tower, which is something that we rarely see here in the US, but we almost mandatorily see in Europe, Matt, right? And we're going to see on slide 5, hopefully getting there, me letting us get there soon, we will see that you can do this sort of just to check the aesthetics of it, which is often done that way, but also to check the performance. So I think if we were to talk to David about it, I would say he's less looking at the Elbphilharmonie, which in all honesty is pretty much a microwave on top of a brick chunk, because it's all glazed without any climate or sun mitigation. And he seems to be more inspired by you guys who spend a great amount of consideration to the bioclimatic performance, which I'm happy to see. And there are these louvers, and they remind us of some louvers we're always sentimental of, DeSoto, right?
Yep. Yeah, that's, if I'm assuming you're talking about our favorite Ala Moana building that had our very innovative exterior vertical louvers, which pivoted on their vertical axis according to what the position of the sun was. They were mechanized to do that. And that was way back in 1961. So you'd think if we were able to do that then, we'd be able to be even more innovative now. And I don't think we've done that here, although I think what Matt talks about in terms of the specifically made metal shades that they created for the building is pretty darn wonderful through this innovative method, another innovation of hydro forming of the metal rather than just stamping it with a regular stamping machine.
Yeah, potentially coming full circle. And one more note on the left column there, which is Jay once provoked us to do a couple of shows about what we call cynical classicism, which is the Trumpian classicism versus cultivated classicism, which we think Chipperfield is pretty much in the tradition of a sort of rejuvenation of classicism. And certainly, Ron reminds us that Ed called himself and was proud of to be called sort of a neoclassicist in an innovative versus a reactionary way. And also, I think Ron is of the same kind of David Chipperfield, the very talented and successful and powerful architect that is very humble and understated. And you see this in what the email of Ron is called. It's basically named after another fellow British man, John Parsons, 74. So I think now maybe I change my email to ronlindgren@roadrunner.com or something.
No, you don't get to do that.
In wanting to live up to that tradition of the humbleness of these people, basically. And again, like as you were touching on the DeSoto on passive systems in not an active way, but in a frozen and not mechanically moving way, as we just experienced just this morning again on my routine stroll through the Halekulani, where we took the students, and I decided to go back today and do studio from there because they got their roll down wind shades down. They're like totally, like a sail, and it's just awesome. We have really heavy winds here. And as I was reading, and we will further when we get to that show, DeSoto, it's too small here in that show, in a pre-show view of at the bottom right, but on the architect's website of Chipperfield, they talk about the louvers, that this sort of second skin that is not made out of glass, but made out of vertical fins and horizontal metal grating is of static nature and not of dynamic nature, again, because of the maintenance issues that we learned the hard way with our favorite Ala Moana building. And that's doing the same, taking the same position. That gets us back, next slide, to your hydroforming. And now, yes, we got that video up. So please, when you want it to run, let Eric know and explain us what we see.
Yeah, so these are just some still images of sort of the pre-process leading up to the fabrication of these shading elements that we've talked about in the past here. You see at the top, my colleague Michelle looking at the molds, the solid stainless steel molds that were used to press the metal into the form and to give it its shape. And then the lower two images here were basically mistakes or sort of throwaway versions where we were experimenting with different thicknesses of stainless steel. We wanted to try to do this with just 1 millimeter thick stainless, but you can see there it just wasn't stable enough. Some of the molds actually tore when they were pressed or drawn very deeply into the mold. So ultimately we went up to 1.5 millimeter thick, but it's just kind of demonstrates that with this kind of technology that is, seldom been used in architectural applications, you need, programming for a bit of trial and error is a wise thing. We knew it would work somehow, but it was fun to test these things in this way. And then I think probably the next slide is this video, which illustrates what happens with that mold that Michelle's looking at when it's picked up and set into the hydroforming machine, and the water is injected into the mold here. So you see that's the sheet of stainless going over the top of the mold, and then it goes into this sort of magical device, and the water is injected through a top that's lowered down onto the mold. And as it comes out here, there's a bit of oil mixed in with the water, but they take that out of the mold then and clean it up, and then it goes through a later series of processes here with a 5-axis robotic laser, trimming the edges, perforating the outer several inches of the panel itself, and basically giving it its kind of final form. Here they were bead blasting the exterior to give it a slightly dull finish on the outside, something that would weather more appropriately for the climate here. And then there's a fairly extensive amount of kind of post-processing of the elements to make sure that the dimensions are correct and geometry all matches precisely to what's been what we modeled. And of course, there's a little bit of human interaction here as they finish these off and put them in crates and ship about 12,500 of them to Boston to be installed on the building.
Matt, I have several questions after watching that. You sent that to me last week. First of all, were any of these just mirror images of each other, or were each of these four completely different?
There were some that were able to be that were essentially like mirror images, right? So you could kind of use two, like on the east and the west. It's basically kind of a mirror of itself. And then there were some. Each of the orientations, northeast, southwest, had sort of subsets of 3 or 4 variants that allowed us to sort of play a little bit with the texture on the outside of the building, and also react to the areas where people are looking out more and where it's just covering up the floor thickness. So some of those were able to be cast out of the same mold as well.
Okay, so there actually you did vary the exterior for some aesthetic reasons in addition to the performative ones too.
As long as the geometric modifications for that are kind of what you called aesthetic, as long as they continued to perform exactly. So you can basically have a sloped surface that can be, either more or less sloped, but then it has to go out further to catch the same angle. So there's, within a certain specific geometry, there's still many variations on that you can do.
Okay. And then one of the things that we've talked about is the IBM building here in Honolulu, in which Vladimir Osipov designed the exterior concrete sections so that they would not collect debris and that birds couldn't roost in them. Mm-hmm. Did you, I'm assuming, made some similar decisions, performative decisions, not just for mitigating light and sunlight or controlling it, but for those keeping things clean, in other words?
I have to say that the geometries that we were studying here for purely sort of solar reasons, sort of almost by definition, were sloping or of a geometry that they mostly shed the snow, is what I've noticed here over now 3 winters. And then of course, birds don't particularly like to roost on surfaces that aren't more or less horizontal. So that worked out pretty well. Yeah.
DeSoto, there's your favorite Massachusetts childhood snow out there too.
No, that's not my favorite. No.
Okay, and going back to, we're really heavy on guys here on the male in this show. Sorry, going back to Michelle, because today is also International World Women Day. So to all the ladies in the world, congratulations. And you showed to us, Matt, at the very beginning, how the office is comprised, and you have at least equilibrium, or it even seems to me there might be actually more power females in your office than male. So
I think we're actually slightly above 50% there. So yeah.
See, there you go. And Michelle, thank you again, was also with us, the little show quote there in a review in the last semester. And there is all the German in there for you, DeSoto. Edelstahl actually means stainless steel, if you haven't figured. And down there, Muster means sample, right?
Oh, okay. I wondered what that was. I didn't know what that word was. And I thought, is that a strange spelling of the word master? Because this is like master. No.
And
R&D is research and development.
Exactly. Yeah, there you go.
That I know.
Okay. And then since we know you guys are people and planet friendly, then the people would say, okay, stainless steel, how sustainable is that actually? And you gave that some thought too, some considerate. And so that gets us to the next slide, and tell us about that.
Yeah, so the original kind of concept for the shading system, we knew geometrically what we wanted to do. We really hadn't figured out how to build it. And so initially we were thinking in more conventional ways about how facade elements like this are built. And very often that's done with aluminum plate, which is fairly light. Aluminum is lighter than steel, but it is not as strong, and it needs more thickness. So, but as we kind of went through this process and began to talk about maybe being able to do it in stainless steel that was either folded, or ultimately what we ended up doing, which is more of this kind of creased and hydroformed stainless steel, we were able to drive the actual material mass down considerably, as you can see here, and the corresponding carbon, embodied carbon in the shading system. So all of this kind of led to in a very positive way, not only in terms of carbon, but also the amount of structure that's needed to hold up this shading system on the outside of the building, and the resulting forces on the superstructure. So it's really, I think, a good story about how engineering components can be optimized really with some creative thinking.
Absolutely, and that you usually don't get in the conventional or traditional architectural realm. As far as Frank Gehry's office, or when Michelle, talking of her, she was trained by Tom Main, under Tom Main in morphosis. And while, Tom, more than basically Frank, is keen on how the building performs in operation, but then again, a building, yes, costs 8 times as much at the end of the life cycle through mainly its operational costs, but also its initial cost, right? So you obviously are already good. You're making a building that then, has a as low as possible carbon footprint in the operation, but you also want to minimize that footprint in its manifestation, in its erection process. Okay, and now that we don't fall short on it again for the last couple of minutes, we're going to show you that facade mock-up that is performative in many ways. And if we can get the next slide up, and actually the moving one. And that reminds me totally, we have a crazy windy day today, DeSoto, right? I mean, this is simulating conditions we have naturally today. And you tell us what this all tested, Matt.
So basically here you see those shading elements kind of aggregated on a section of wall that's representative of, I think this is 2 stories tall, I think, or maybe even 3, with each of those modules every 6th module is a floor height. So what we wanted to test here was the integrity of the structural system. So this is basically all erected on high tension stainless steel rods that span from the bottom of the wall to the top, and then just are connected horizontally by the shading element itself. So we wanted to test that, the actual sort of movement of this system and the kind of the visual effects. We also were beginning to test here the acoustical performance of the perforations in those panels. So we wanted to make sure that there would not be any whistling or unfortunate noise generated by those perforations. And that's all done here at the factory site of the fabricator, which was Joseph Gartner in Gundelfing in Germany, southern Germany in Bavaria, with one of their 2 giant, that's actually an old airplane propeller. That's what's traditionally used to perform these kind of wind and water tests.
And that's very important. DeSoto reminds me of one of the other tragedies of buildings that aren't anymore what they used to be. This one is even more tragic because the Ala Moana building, hopefully they at least retain. But my employer at has announced that they want to tear down Kuykendall Hall, which is by our hero Takashi Anbi. And that one, as we were pointing out in the respective show we did, had originally also vertical shading fins on, and one of the excuses they took these off were rattling. They were rattling in the wind, and it is very windy up there. So, we're saying even if that was the case, well, then that was then and now is now. And one could be smarter these days and can retrofit that, right? But back to the original, because they made sense. But again, for all the designers, architects around, especially in areas with high wind, as we have it here, especially today, you might want to consider that. And as you said, DeSoto back then, under Ahupua'a and the more analog, now we have, as you Matt show us, a mixture of analog and digital tools that we can all sort of, predict that and also then sleep better, because then, we know more that it actually works, and our clients won't be disappointed. And
I have to admire the high tech that's been on display here, that the fact that this factory's got an airplane engine to test that in the whole world. I mean, no, really, how many places are you going to be able to do that in life?
In the States, there's 2 locations where you can do this. I believe one in Miami and one in Pennsylvania.
That's only 2 in the entire country.
And potentially here, because I don't know if you realized, I'm sure you did, because they're flying over you constantly. They changed the routes for the planes coming in as of yesterday. I was like, what is that? Are these like fighter jets, which we unfortunately have more than before as well, for unfortunate reasons. But these are the passenger trains that they decided to fly over you and me since yesterday. So we got plenty of airplane engines here.
Yeah, that's the wind, the direction of the wind. But they also, for like this week, the military planes are flying in a different pattern too. So in addition to the wind noise, we're getting a lot of airplane noise. That's just another whole subject of noise. But you did say, Matt, that part of this was to determine whether these were not going to make noise in the wind. And that may seem trivial, but it is not. And if you've got something that's constantly making noise, it is actually damaging to your body to have to endure that.
Yeah, ultimately, these had to be taken to a lab to have that testing done at even another level of detail. But this was the beginning. Yeah.
Okay, and this is also the end of the show now at the same time. So we're at the end of another exciting 30 minutes. And guess what? We will show you more levels of development. Next time, we're going to start out with a construction document of the whole thing. So stay tuned for that. And until then, please stay biclimatically beautiful, beautifully biclimatic. Bye-bye.
Bye.
Thank you so much for watching Think Tech Hawaii. If you like what we do, please like us and click the subscribe button on YouTube and the follow button on Vimeo. You can also follow us on Facebook, Instagram, and LinkedIn, and donate to us at thinktechhawaii.com. Mahalo.